we quickly look at 429, some of those pages are things you should already be able to do. Notice that, I think we might have touched on some of them, but the format of the questions is important because the two final written response questions on your final exam, number 7 and 8 specifically. Number 7 is, here are the structures, name them. And then number 8 is, here's the names, draw them. Now there are also some multiple choice questions in the some questions in multiple choice on organic chemistry. But what Meg has asked you to do here is exactly in keeping with what you're going to see on the final exam. And to the extent you are able, because you have one test left and it's the final exam, pretend you're writing that exam when you go to answer any of these things. You should be able to answer all of them. And if you haven't practiced the protocol, what do I do? How do I start? If you don't know, don't quite have it straight where the commas and where the hyphens, that type of thing go. The only way to get comfortable with that when you're in a test situation is to practice it. So how about B? Now that didn't show up too well on the screen here, but it does show up well in your book. What's the first step to naming a diagram? Find out what the word ends with, right? And draw that thing from which you generate what the word ends with, right on what it is you're trying to name. So the longest chain is what? 5. What is on that chain besides hydrogens? Hydroxyl, which makes it a what? An alcohol, which means it ends in what? So what is the last word of this name? 1 hyphen pentanone, right? Circle whatever isn't the longest chain and then name those things alphabetically. So not only what do I do, but you got to memorize what those things are. You got to know that you name them in alphabetical order. So the first part of this would be 2 hyphen bromo. So that's carbon 1, that's carbon 2. If we're naming it as an alcohol, which we are, that carbon is carbon 1. So it would be 2 bromo. Then there's 2 things on carbon 3. One of them's a chloro. One is in the best. Chloro comes before M, but after B. So it would be 2 hyphen bromo hyphen 3 hyphen chloro hyphen 3 hyphen methanol 3 hyphen methyl hyphen what? 1 pentanone. So I believe we might have done this last class, but to generate that name correctly in its entirety is something you should be able to do. And if you haven't yet, do it. Okay? Then check your answer. 2 bromo, 3 chloro, 3 methyl, 1 pentanone. And again, the appropriate hyphens and commas if necessary. And C, I believe we named that one too, didn't we? 1, 2, 3, 4. 1 comma, 2 comma, 3 comma, 4 hyphen, and 1 word, tetrachlorocyclobutane. What's the name of E? That's a carboxyl, making it an acid. That's always carbon 1. You never need a number. 1, 2, 3, 4, 5. Drop the E of pentane and add oleic acid. What about, did we draw these structures? What about E? What would you do there? What's the first thing you do when you draw a structure? Go to the end. In the same way that when you're naming a diagram, you find out what the word ends with. When you're drawing from a name, you go to the end of the word. So 2-hexanol means we've got a hydroxyl on a 6-carbon chain at carbon 2. I would never ask you to draw condensed structural formulas, just draw structural formulas. Don't forget at the last step, put all the hydrogens in, because you need those. So start here, and then go from If you do it systematically, it's very difficult to screw it up as long as you know what chloro and methyl and OLC is. Always check your answers. In F, we have a cyclohexanol. So you could probably get away with a skeletal diagram here, but if you're going to draw the whole thing, 1, 2, 3, 4, 5, 6. This is still a saturated compound. Every carbon still has 4 atoms it's attached to. Cyclohexanol, meaning whatever carbon you put the hydroxyl on is on carbon 1. So we put an OH here, that becomes carbon 1. 2, 3, 5 tribromal. Well, you either numbering counterclockwise or clockwise. Put a bromine there, bromine there. So 1, 2, 3, 5. And then the rest are just hydrogens. Okay. Exactly the same molecule if you called that carbon 1 and that carbon 2, 3, 5. It'd just be that thing, look out the other way. And it would help me mark it if you did those things, right? Now the skeletal version of that would simply be a hexagon. And OH here. Number 10, she says, for each of the following compounds, classify the compound according to its functional group. For some compounds, more than one functional group may be used. Draw condensed structural formulas for as many of these as you can. Well, sometimes she mixes up functional groups as far as I can see. There's really only one where she puts 2 functional groups in there, and that's this one. We've got a halogen and we've got a hydroxyl. I wouldn't ask you to name amides, but any other compound in that list you should be able to draw.
Sorry, so everyone except little.
Instead of everyone except F. So what about number D, 1,2-dimethylbenzene? There's a couple ways to name that. For benzene, you can pretty much always start with the skeletal version. So that's just benzene, C6H6. Each of these carbons has 1 hydrogen. 1,2-dimethylbenzene is that. Because every carbon only has one of the bonding sites. Remember we talked about you can only disubstitute a benzene as a 1,2, a 1,3, and a 1,4, right? We also talked about what's the common name for 2 methyls on a benzene. So what would the most streamlined way of naming that be? 1,2-dimethylbenzene is correct, but most organic chemists wouldn't call it that. Toluene's 1 methyl, what do we call 2 methyls? Xylene. And what is a 1,2 position? That's ortho. So the most streamlined way is just orthoxylene. Sometimes even abbreviated further, O-xylene. Okay? O standing for ortho, so that's ortho. That's meta, and that's para. So 1,2 is ortho, 1,3 is methyl, 1,4 is para. So if I drew that, you could name it that way, or you could do 1,2-dimethylbenzene, or you could write it all out. Orthoxylene, that's fine. Yep.
Just going back to E on page 429, can you just go over how to draw it? Because I'm looking at the answer key and I'm a little bit like kind of confused with the order
How
that they're.
did she draw it as a condensed?
Yes, she did, but she has the 1,1-dichloral, but then she has the dimethyls coming from the opposite direction on the 3 from starting at the
Really?
right side. So like, how should it
Does
be?
she have the hydroxyl between the methyl and the chlorines?
She does, but it's like it kind of comes from the other
It's
way.
if it comes from the right or comes from the left, it's the same molecule.
Okay.
Just looked at it from a different side, so
So you can just switch sides?
yeah, I mean, what I normally go left to right. But
Yeah.
If you want to go right to left, that's fine. So let's start with the end of the word. 2-hexanol is 1, 2, 3, 4, 5, 6. Let's put a hydroxyl there. So that's 2-hexanol. If all those things are hydrogens, that's just 2-hexanol, right?
Mm-hmm.
So 1,1-dichloro, you could have 2 chlorines anywhere on that carbon. So let's put them there. That's 1,1-dichloro,
Mm-hmm.
3,3-dimethyl, 2-hexanol. That's where those methyls have to be because that's carbon 2. If she has them here, it's wrong.
Okay.
That's carbon 2 because we're naming it as a hexanol. So that's the only other way to draw that would be to call that carbon 1, put 2 chlorines here, a hydroxyl here, and the methyls here. It's just that thing looked at from the other side of the board.
Yeah,
It's the same.
because on here she has both the methyls moved over onto the next carbon to the
On
right.
this one?
No, the one to the left of that.
On the one in the book, she has the methyls here?
Yeah.
That's wrong.
Yeah, that's what it has.
Yeah, that's wrong.
Okay.
Because that would be 1,1-dichloral, 4,4-dimethyl,
Yeah.
2-hexanol. So yeah, she's wrong.
Okay.
That's unfortunate. I wonder if she got one of her students to do that. I apologize on Nate's behalf. What about C? How would you draw C? Trans 3-hexene? Now, if there was other stuff on that 3-hexene, then it would have to come between the trans, which starts the word, and the 3-hexene, which ends it. But to draw that, we've said before that trans arrangement is like a staircase of the chain, but you don't have to draw the chain like a staircase, just draw it straight. 1, 2, it's a 2-hexene, sorry, 3-hexene, so that, 4, 6, 1, 2, 3, 4, 5, 6. And then just do that. 1 up and 1 down. We'll put that up and that down, doesn't matter. Right now, that's just trans 3-hexene. And that's all she's asked you to do, so don't forget to fill in all the hydrogens, okay? No matter which side you number it from, the first carbon of the double bond is on carbon 3. If we had other groups, then the side we would number from would obviously one, we gave the groups a lowest combination of numbers, because left to right is still a 3. Well, let's say we had, I don't know, a methyl there, and maybe a methyl there, and a chloro there. You'd number it from left to right. But the word would still be trans at the very beginning, then all the stuff in between, and then it would end with 3-hexene. Right? So, just for interest's sake, what would you call that if I gave it to you? What would that compound be called? So take yourself to the Tuesday,
Yeah.
and you're sitting down and writing your final exam, and I said, draw that, what would you do? Or name that, what would you do? The word would begin with what?
Trans.
Right? And it would end with 3-hexene. But because the groups are down at this end, we got a number from left to right. As far as the position of the double bond, it's 3 either way, but because the groups are down here, this would be carbon 1. So Cl comes before M, so trans 1 hyphen chloro hyphen 2 comma 2 hyphen dimethyl hyphen 3 hyphen HC. So this stuff is what's substituted onto the trans 3X. Classify the following molecules according to their functional groups. Well, we can do that, but for some of them anyway, you should also be able to name them. What would this be called? First thing you got to do is identify what class of organic compound it is. What is that thing? An alcohol. The carbonyl is at the end of a chain, which makes it a what? This is a carbonyl, right? If it's at the end of a chain, you see one hydrogen on it, that makes it an aldehyde. And when you name aldehydes, you drop the E and add AL. So knowing that, what would you call A? Sorry? Do you need the 2? In other words, that can't be on this carbon because it's already got 4 bonds. If that methyl's on here, what do we call it? What if this methyl's here? Agreed. That's butanol, isn't it? 1, 2, 3, 4. So you don't need the number because that methyl can't be anywhere else than carbon 2, or it wouldn't be propane. Aldehydes are probably the easiest things to name. Okay? You don't need to position like you do for alcohols. You still just change 2 letters, but you never have to indicate a number because it has to be on carbon 1. It's the same as acids, except with acids, you got to add OIC, new word, acid. When we're talking about acids, what would you call B? Benzoic acid, exactly. Without this, it's just benzene. But that's benzoic acid. It uses a flavoring and a food preservative. What's C called? Still got a carbonyl in it, but it's not at the end of the chain, it's in the middle of the chain, which makes it a what? Ketone. You're not writing these names down, you guys. I'm going to ask myself, why not? Okay. Well, if you've written them down and they're correct, then great. So what would the name of C be? No 2, right? This one? 1,1,1 trichloro, I think, right?
Mm-hmm.
Did we name E?
No.
E is the active ingredient in antifreeze.
It's an alcohol.
This is an alcohol, but it's called a diol. I would expect you to name diols, but diol means there's 2 hydroxyls. Because they're on different carbons, the formal name for this thing is 1,2 hyphen ethane, and just one word, diol. Commonly called ethylene glycol. And usually you mix it 50-50 with water, and because the amount of hydrogen bonding in there, it's got quite a high boiling point, so it elevates the boiling temperature of your liquid cooling system, so it stays liquid at temperatures higher than 100 degrees. It also lowers the freezing temperature. And I don't know for certain, but apparently it tastes sweet. And what they do to it, so that they prevent you from missing it on your driveway, because it's colorless, is they add fluorescent to it, which is a fluorescent dye. So if you ever looked at antifreeze, it's a bright fluorescent green, and pets will still lick it up, but at least you can see it on your driveway before your pets do. And if they lick it up, what happens when your body metabolizes it is it turns it into crystals of oxalic acid. And those crystals build up in your kidneys and you die. Okay. The dye they add to it is called fluorescein. This is fluorescein. Every year they throw this stuff into the Chicago River on St. Patrick's Day. And in the sunlight, that looks bright green. Under ultraviolet light, it turns green. So what they used to have, when I was there in 2015 for a science conference, Saturday morning, it was I think a day or two before St. Patrick's Day, which is on March 13th, I believe, or March 17th. They have a fireboat that went up and down the Chicago River, which runs right downtown, and this fireboat dumped off this orange powder, which is fluorescein, on the back. And then a bunch of boats stirred it around. So after about 7 or 8 passes, the river was bright green. And it stays that way for a couple days. Apparently it's non-toxic. Okay? If you Google Chicago River timelines, St. Patrick's Day. I don't know if this has sound or not. Obviously not. I don't miss this. Maybe there's
Why would the lines are two? Are you sure?
sounds not.
Except backwards? No, what I mean is there's like two.
I think this is 2022. Now they just spray it in the back. They used to just shovel it off with screws. And the river is just lined with people who watch it, right? And then after the river is bright green, they just turn around and go across the street and start drinking at an Irish pub. So I was like right there, and there's an Irish pub right here. 9:30 in the morning. It's even better in the sunlight. The sun comes out, you can see it goes nice bright green. That thing is there just to mix it up. That's what that was there for. They do that every year. And that's the same thing they add to that's the same thing they add to ethylene glycol, so it doesn't kill your pets. Have you ever had your eyes tested? And I don't know if they do it anymore, but what they used to do to dilate your pupils, they used to put a little drop of fluorescein on your eye, and then your pupil does like this, and then they remind you, don't forget to wear sunglasses when you leave and go outside. and you kind of have to
Just change.
blind her, but that's what they put it to, drop it to her that on here. Anyway, this is colorless, but not when they add this to it, right?
The last one that you were also looking for. You found?
It's 11A.
11A. I see methyl
Okay, I'm
But it's propanol.
because it's the aldehyde, right? Because I told you I'm
Don't
get
Can you remind me? Say the name again.
Methylpropanol.
So what's the longest chain?
Longest chain is 3. You don't need to
It is 3. Okay, thank you.
Let's see if this versus.
Because it would be the same starting from either side.
But if you
So in the sunlight, you can imagine that it's a
propanol,
nice bright green.
you need to know. So left longest chain would be 4. Give it to right longest chain would be 4. So let's stay there.
Anyway, I digress.
Wait, say what's this called? Methyl.
Propanol.
Following molecules are organic compounds.
Like 5 chemicals.
Circle of functional groups. Well, most organic compounds that we're familiar with have multiple functional groups. This is an aldehyde. It's also an ether. It's also an alcohol. There's also an aromatic ring there. So vanillin is usually considered to be an aldehyde. Here's morphine. This bridge here, that, as we've said before, indicates it's coming out of the board. So what we have there is a CH2 and a CH2. And it basically connects this nitrogen via that bridge to this carbon. But that itself is a functional group. We've got an aromatic ring here. We've got a hydroxyl there. We've got a hydroxyl there. That part of it makes it an ether. Aromatic ring. That makes it an amine. And we've also got a double bond here in this portion of the multiple rings. That would just be cyclohexene. So remember, it's not just different atoms in carbon and hydrogen, it's an arrangement of bonds. Double bonds, triple bonds are themselves functional groups. This is ibuprofen. We've got an aromatic ring there. We have an acid portion here. That's really the only 2 functional groups. So we've got a carboxyl here and we've got an aromatic ring there. This is capsaicin. This is the business end of pepper spray, or in a more concentrated form, bear spray. In bear spray, it's illegal to spray bear spray on a person. I've never had to use the bear spray I have on a bear, but apparently it'll stop a grizzly at 40 feet. It's pretty nasty stuff. Okay? I only got it because there was this pit bull that used to chase me on my bike. He doesn't chase me anymore because I use this. Yeah. So pepper spray is the same stuff. It's just less concentrated. There's penicillin. This is the first example where we see a sulfur there. Here we have an acid portion. This nitrogen, carbon, carbonyl, that makes it an amide. Then there's another amide portion here. Aromatic ring there. This one's caffeine. Notice we've got nitrogens in both rings. This portion and that portion are amides. That is also an amide. This portion of it is just an amine. We've got a double bond there, we've got a double bond there. Theobromine. What do you notice about that name and that structure? There's no bromine in it, right? So to be honest, I'm not sure why they call it theobromine. Apparently that's the chemical in chocolate that makes you feel really good when you drink hot chocolate. So that brings us to the most applicable part of this chapter. What we've done up till now is basically just catalog, identify, okay? And you guys, you all have this, right? Now, you're not going to need to memorize that for the test, or take it when you go to post-secondary. That's why I punched only grade. It's more complete than what May gives you, right? And you're probably going to have to know how to name all of those things when you go to post-secondary, when you take organic chem, which is usually at some point in the first year, then for sure, most likely in years after. Okay. Unsaturated fats such as those found in olive oils and avocados are healthier than saturated fats found in coconut oil and butter. What do the words unsaturated, saturated mean? Ever heard the term unsaturated fat? Unsaturated fat. Ever heard the term polyunsaturated fat? What does saturated and unsaturated mean? Forget the connotation of fats. Just what do those two words mean in terms of a hydrocarbon? Yeah.
It's like all this full, it's like God.
Yes, but in what sense? So in other words, if I have a saturated hydrocarbon, that means that every carbon in there is stuck to 4 other atoms. Okay? Every one of carbon's valence electrons is used to connect it to another atom. So the molecule is saturated in terms of the number of atoms it contains. Unsaturated means it's not, because at least in one place, we've got a double bond between 2 carbons. And every time carbons are bonded from single to double, we have to remove 2 bonding sites. So the simplest way of demonstrating that is ethane, which is C2H6. To make it into the simplest alkene, I have to take away 2 hydrogens. So notice it's no longer CnH2n plus 2, it's CnH2n. That's an unsaturated hydrocarbon, the simplest one. A double bond is stronger than a single bond, but it's more reactive. Meaning when your body's metabolizing a fat that has a bunch of double bonds in it, it's easier for your body to break that fat down, because every position where a double bond exists is more reactive. Your body has to spend less energy to metabolize that fat. And some people don't know this, but there's more energy in fat than there is in carbohydrates. So an average fat molecule, in terms of molar mass, will hold about 2.5 times the energy than a carbohydrate molecule. Polyunsaturated fats mean, poly means many. So a fat, I kind of wish Meg would have explained it sooner than she does, but if you turn to top of page 437. I'll give you a crash course in fats or lipids. So, when you see 2 names like that, one ending in YL and one ending in ATE, what class of organic compound did we have to do that for? Remember, it mattered what we stuck to what. We connected 2 classes of compounds together. Remember when we connected an alcohol to an acid, we got a what? Started with an E. S. Ester. Okay. So, this is a molecule of fat, or a lipid, same thing. It's made by connecting glycerin, which is this molecule. Glycerin is an alcohol, but it's got 3 hydroxyl groups. It's also called glycerol. So, see if I can draw it the way she's put it there. This is glycerol. Now the formal name for it is 1,2,3 propane triol, because it's got 3 alcohols. It's a really thick liquid. It's the same, we also call it glycerin. It's a thick, colorless, almost a syrup. And it's thick because of all these hydrogen bonds. A lipid molecule has glycerin stuck to 3 long, what we call fatty acid chains. We call them fatty acid chains because they're really acids with a long hydrocarbon portion. And let me find another color that actually works. That's a different color. Okay. So it's probably matched. Yeah. So you got orange, but you probably can't see. You guys can see that, right? So look at these 3 chains. That and those 17 carbons would have come from this.